Hello there, this is my demonstration for my parser for Luke Evans. So in this video I'm going to show you a step-by-step guide in how my compiler operates. So first I'm in the compiler environment. I'm just going to show first off my files. The main two ones that will be needed to test whether the compiler is working is target, which as you can see now is empty, which will eventually have my assembly code within. And the next one is token, which will be filled with all the tokens that come from the compiler. Also, this will be the input file I'm running through. You can see I have variable declarations in, addition, if statements, print statements, if else statements, should I say, sorry. Some more variable declarations just to make sure it's all working, different types, as you can see. Here we have the printf working with integers. Here we have it working with words. So these are the main operations being tested. So the first step I will do is nano grammar.l. Here you can see this is the grammar for my lexical analysis. As you can see here, we have these are all pattern recognition for my input. So the compiler is able to recognize these words being used within the input and generate a token for them, as you can see here. Some use different formats, but overall it's pretty similar, just returning keyword for each of them, which will be the token, which the parser can then use later on. We also have regular expressions. As you can see here, these do certain types of things. Down here, this one's used to skip the white space, this one is to skip comments, and this one is to skip multi-line comments. Down here in the write to file, this is about writing to the token file, and this is how the token will be made up of. So, symbols, and then the data of what the actual token is, and then a closing symbol for the token, just to separate all of them individually so the compiler is not confused with anything. These are all the operators. Some are different, some are just the symbol. Certain ones mean certain things. So we have two equal signs, which will equal the result. Not equals to, less than, and then greater than. So that's about it for the lexical analyzer. So I'm just going to exit this, and then I'll show my parser, which is called nano grammar.y. I'm using nano to open it. Here we see a number of items. These are libraries being used. These are to be called later. My void generate for the assembly code. Functions will be called later on within it. We have tokens. This is declaring the tokens that will be in the token file, so that can be used within the parser. What else do we have? Declaring my statements. This is very important because with these statements I have to give a grammar rules for the statement. So this is first just declaring the names of them. Then as we go further on down, this part is giving the rule. So saying if you find this token, do this with it. So we will be printing for each of them past a what and then the name of the statement. This will be printed within the terminal itself once we've run the executable file. Further on, declaring the expressions, terms and factors down here, as you can see as well, the same message passed and then the name of it, just so it checks whether everything is being passed through. Further on down here is one of the very important parts. This is what will actually generate my assembly code. So as you can see here, here's the function name again that we saw at the top, so it's calling it. There is also a call for it on each one, so if the statement is found, it knows which function to go for the assembly code. It's not just picking a random one, each one has their own assembly code generation. Each one will say character target and then write file to target. This is so the assembly code is being sent to the target file. And then these symbols are, well, these strings of characters are the assembly code for the individual function. So we have a for one here, we have an if one here, the print, and then the variable declaration one here down here. The write to file is the same as what we saw within the lexical analyzer. This is opening up the file that is here. It is appending it with data, and then it is closing the file. Within the main function, this is what the executable file will be calling. This is finding the external file, as it's in the same folder, but it's external still. And then one way in, it's putting the input text through, and then one way pass takes the tokens from one way in that it's found within input file, and passes them following the grammar rules to assembly code. So the YY pass has to be within here. Okay, so now we are going to run it. So first off, we start with flexgrammar.l, which is the this is the command for my lexical analyzer, so I'm just going to run that. This grammar.l will generate a C source file, as we can see here, lex.yy and then C source file down here. We will then do, there we go. We will then do bison-b grammar.y. So bison is the parser. So this we do here, run this. This will access grammar rules from grammar.y for the tokens created. It will create another grammar file and header file within my folder. So the other grammar file is here, and the header file is here. Within this header file, it has stored tokens, and the declarations, definitions, and data types of each. The grammar file has contents of grammar Y. So this is a token declarations and etc. And this will be my parser's grammar within here. These warnings are fine as it is a C compiler, so we don't have to do anything with these. The next command will be gcc-o parser lec.yyc grammar.tab.c-lfl. And this one has multiple roles, should we say. These warning signs, again, as I said, are fine. We can ignore these. It's not saying error. If it said error, then that means a part of the compiler is not working. But these warnings are okay to leave. So with this command here, gcc, the gcc-o parser, this is renaming the executable file to -parser, which we will call later. The lex.yy and grammar.tab.c compiles both the lexical and analyzer and parser, and then the -lfl links to the flex library for the support functions for the lexical analyzer. So we're not creating any error codes here. And then the final call we will make is -parser, should I say, sorry. This is the executable file as we just named it previously, in executable command, should I say, as we renamed it within the gcc command. Here we can see it's passed everything within my input file. These stating what it's done and in the order of the input file ran. As you can see, there's a few different ones: declaration statement, integer, float, assignment statements, if-else statement, and then print. That's pretty much what I've done, just different forms of it, just to make sure it runs using different methods. And then, so once this is done, we can go within my folder, we can open up the target file, and now you can see it is being appended with the assembly code data. Yeah, there's not much more to say about this. This could now be run on a targetable file. So this is now the assembly code of what I pass through of my high-level language within the input file. We can also go into token, and here you can see the token name and what the token is on each of them. Yeah, it's pretty straightforward. Just declaring token name, value of token here. So we have integer, token name, value 14. That is about it of my compiler. We could just talk about here more. Here we have executables. This is an executable application. Some of these are not needed anymore. This was just from when we were building the lexical analyzer. So, but obviously the commands changed once I started to build my Bison, so you could do it all in one. So, like, for example, this output file is redundant as now, as well as this one. These aren't needed anymore, but yeah, that is about it. I hope you have enjoyed listening, and thank you for listening. Bye bye.